Okay. So, see, first of all, we are going to focus on connecting to computer as I told you yesterday also. How to connect computer and how to make communication between computer. Now, one more thing I told you in last class that the basic requirement of communication is source MAC, destination MAC, source IP and destination IP. So the first thing which is coming in my mind is Praful, who will provide these addresses to the machine. So guys, there are two types of address in the network. One is MAC address, another one is IP address. We'll start IPv4 addressing soon, and before that MAC address also. But for now, keep in mind the MAC address will be assigned to device by the manufacturer company. Who is going to manufacture the device? They will hard code the MAC address on the NIC. Right? Address belongs to guys NIC, not the device. My laptop can have multiple address. If I will show you my CMD here, if I will show you my CMD here, and I am going to run command ipconfig all, which is used to check the configuration of my device. So you can see lots of IP addresses are there. One is 192.168.1.2. One is 192.168.241.254. Another one is 192.168.161.1. Right? So multiple IP addresses are configured on same machine on the same computer. That means this IP address does not belong to machine, computer, my laptop. Right? So on my laptop, we have multiple NICs, network interface card, which is the first networking hardware which we are going to learn. When I will start networking device, you will see first device is NIC, network interface card. And on the NIC, company is going to hard code the physical address, this address, physical address. For all the NICs, you can see I have physical address on all the NICs, physical. So this address is assigned by company who have manufactured this computer, and the IP address, who will configure the IP address? Network engineer. We are responsible to configure IP address on the machine. We are responsible to configure IP address on the machine. So for an example, here I have configure IP 10.1.1.1/24. Might be possible someone don't know what is /24, right? What is network ID, subnet. So don't worry. IP address is what? Address is what, guys? What is your name? Your name is unique identity. It is your unique identity which we are using, right, to identify. Like name can be duplicate also, right? My name is Praful. Someone else can also have same name, Praful. But if I am going to combine my physical address with my name, then I will get unique address, because my physical address is globally unique, which is only one on the entire planet. Right? Is there any other Gujarat, Surat? No. There is only one India, one Surat, one Gujarat. So if I am going to combine both the address, I will get globally unique address. In the same way, machines are also using two types of address. One is physical address, which is MAC address, and another one is logical address, which is IP address. IP address can be duplicate also. Multiple machines can have same IP address, but the MAC address is physical address, like your physical address, globally unique. Okay. So, but machine needs both the address to communicate. We'll see these IP addresses in detail later, right? With maybe after 2 to 3 class, we will be starting MAC address and IP addressing. There we will discuss it in detail. This machine have IP 10.1.1.2. So for now, you can assume that this is address identity of PC1. This is identity of PC2, logical address, and this is physical identity of PC1, physical identity of. Question: can PC1 and PC2 communicate here? can I send one file from PC1 to PC2? Yes or no?
Yes, it can communicate.
Can communicate?
Yes.
Now, guys, PC1 belongs to different vendor and PC2 belongs to different vendor. For an example, this is Dell PC and this is HP PC. Now, can they communicate?
Yes, of course it will.
Of
Because
course,
yeah.
of course they can communicate. Doesn't matter the vendors. But guys, earlier it was not able to come. Before OSI model was not able to communicate. Our first topic is going to be OSI model only. From OSI model, we will start the course. From OSI model, we will start the course. So just I want to make you understand one thing. Why? In the last class also I told you, we will focus on three things. Why, what, and how. Okay. So for next few classes, 2 to 3 classes, you need to keep this topology in mind. This lab in your mind. There are two PC, both are connected. Right? It can be PC, it can be any other networking device, server, printer, IoT devices, mobile phone, tablet, laptop, any device, router, switch, firewall. Two devices are connected and both belongs to same. Okay. And our first topic is OSI model. OSI model. Question. Here I am going to put question mark. Why we need OSI model? Anyone?
Between two different vendors are not able to communicate with each other. That's why
Correct.
OSM model is needed.
To make communication possible between different vendor devices. Means before OSI model, different vendor devices was not able to communicate. Dell cannot communicate with HP device. Dell can only communicate with other Dell devices. HP can only communicate with other HP devices. So that's why we come up with OSI model, right? So what is OSI model? How OSI model works, layer, everything we are going to discuss. First, understand why earlier Dell's and HP was not able to communicate with each other. What was the issue? So guys, there is one terms called protocol. Protocol means rule, which is not only applicable in the network, which is applicable for us also. Protocol, right? I will talk about the networking components, the very basic networking components. So in the network, you should have one sender who will send the data. You should have one receiver who can receive the data. You should have media through which we can transfer the data. It can be wire or wireless. Receiver, media. Then there should be some kind of information, data, and after that, right? So now I am not interested to discuss sender, receiver, media, data. I am interested to discuss what is protocol. Anyone have idea?
It is kind of set of rules,
Set of rule,
which is
very good.
which is they their services only talk in those set of rules.
Correct. What is the rule for us? What is the rule for us for this particular training? Let's say for this particular training, we have one rule that, hey Praful, if you are going to teach everyone, you have to speak in English only. You are not allowed to speak Hindi. Yes or no? This is what rule for me. Correct. If I am going to use guys other language, my mother tongue, you will not understand. So this is a rule for me that if you want to teach everyone, you have to speak in English only. Right. So for an example, here on the PC number one, I have one data. Data is hello. Data is hello. Right. So guys, I write hello in the English letter. Right, so PC1 know the English letter, make sure PC2 also know the English letter, then only PCB can read it. Otherwise, PCB cannot read it. So make sure whatever language we are going to use to make communication between PC1 and PC2 should be the same. Then only communication can happen. Otherwise, communication is not possible. For an example, another example. See, my data is different. My data is love letter. I am going to send one love letter to my wife, to my girlfriend. And between source and destination, for an example, my father is there. And I have dot. What if my father will read the information later? What will happen then? So I am going to encrypt the letter. Right? I am going to encrypt the data. Actual information is I love you, for an example. But I don't want to make it readable for my dad. Even if my dad will got the letter, they should not be able to read it. What I can do? I can change the language. I can say 1, 4, 3. This is nothing but the encryption. Changing the format, or I can say I equals A, love equals B, and U equals C. Now, instead of sending I love you, if I am going to send ABC, guys, can PC2 understand it? What algorithm I am using here? There is one algorithm. That algorithm is called, in that algorithm, A equals nothing but I, B equals nothing but love, and C equals nothing but you. 1 minute. Right? So I have one algorithm through that algorithm I have encrypt the data. I have encrypt the data. You might have heard about MD5. Right? So in the Google you can try. You can say MD5 calculator. So whatever data you are going to put to this algorithm, it is going to find one hash value for you. Right? For an example, if I am saying here I love you, it is going to create one hash value for me. Right? So algorithm means like a juicer. In the juicer, if I are going to put apple, I will get apple juice. If I am going to put orange, I will get orange juice. So algorithm is similar like juicer. We have one algorithm where if I am going to put something, I will get some output. Right? So see, two hash value are there. One is this one is this one. Even if I am going to change one letter in the data, my hash value is going to be different. Hash value is going to be changed. So this algorithm is used to identify the data is modified on the link or not. So these are what? These are whatever algorithm this sender machine is using to calculate the hash value. Receiver machine should already have idea about that algorithm. Whatever language I am using to teach you, you should already have knowledge about that language. This particular thing is called whatever algorithm here I am going to use to encrypt the data. Receiver machine should already have knowledge about that algorithm, so that when receiver machine will receive 1 4 or ABC, they can decrypt it. They can convert the data again into the actual format. This particular thing is called. So guys, earlier before OSI model, all the vendor devices has their own rule of communication. All the vendor devices has their own rule of communication. This was the main reason why two different vendors was not able to communicate. OSI stands for what? What is the full form of OSI?
Open system interconnection.
Open system interconnection. connection.
Next, sir.
Connection. So what is OSI model? First, why we come up with OSI model? To make communication possible between different vendor devices. Now, how it is possible? You tell me how it is possible if I want to make communication possible between all the vendor devices, because it is not possible to purchase single vendor devices. Can everyone purchase single vendor devices from the deal only? No. We purchase devices according to our requirement, according to our budget. Some people are using Apple laptop, some of you are using Dell, some of you are using HP, some of you are using different vendor devices. So for every networking devices, you can see multiple vendors are there in the market. You are popular, you are not much popular, but we have lots of vendors. It was challenge in early days. Even we didn't design computer for exchanging the data. First we designed computer for guys gaming purpose. Then we started using it in the calculation. Then we thought, okay, we can use it to share the data also. We can form the network then. So all the vendor companies started working on it. How to make communication between two devices. How to exchange data between multiple devices. And everyone, all the vendors had designed their own process, own protocols. Then OSI designed one common process, common rule for the communication. Common rule for communication. And then we have distributed that to all the vendor devices. If you want to connect your network to the, if you want to connect your device to the internet, you have to design your hardware and software in this way only, by following this process only. Getting my point, guys? What I am trying to explain.
Yes.
So the need of OSI model, hope it is clear. Make communication possible between different vendor devices. Now let's understand how and what is OSI model. So guys, OSI model is nothing. To understand OSI model, let me give you one more. Whenever we are going, leaving the home for office, let's say, I am going office in the morning at 10 a.m. every day. At 10 a.m. every day. So there are some tasks which I performed before leaving the room. For example, task can be taking bath, taking breakfast, taking my car key, dressing. These are what kind of tasks which I perform every day before leaving my room for the office. In the same way, for an example, see there are two devices, two computers. They need to send some file. They need to send some file. Computer A. Here I have one file. Right? I want to send this file from computer A to computer B. So computer A have to attach information like address of the destination device. Your IP address is 10.1. C2 IP address is 10.1.1.2. Right? So if PC1 want to send this file to PCB, PC1 have to add destination address with the file plus there should be destination address, source address. If you have one letter and you want to send letter to your friend, just think, can you send the letter without address? No. You are going to put the letter in the envelope, and on the envelope you are going to write the source address, destination address. After that you are going to hand over it to postman. Am I right? In the same way, this PC also have to put this file in envelope, and on the envelope they have to attach address. Right? So here is my actual information. After that there will be source address 10.1.1. There will be destination address 10.1.1.2. There will be source MAC A, destination MAC B, destination MAC B, and many more informations are there. We will discuss about those later. These are the basic info that is compulsory. Send this file from computer A to computer B. Without this address, I cannot send it to computer B. Not possible. Can we are you going to add this address with this file? See, if I am going to type www.google.com in the browser, will it ask for IP address of google.com, guys? www.google.com. Will it ask me for IP address? No, directly I am getting Google page. That means all the tasks my machine is performing automatically, correct? My machine is performing automatically. So any task in the networking can be performed by two ways. There are only two ways to perform any task. First way is manual. Manually, we can do this. For an example, configuring IP address on the machine. We can configure the IP address. We can configure the IP address. Simply I can open my NIC and here I can change the IP address. Go to Ethernet, then properties, then IPv4, and here I can configure the IP address. Another way to configure IP address on machine is protocol. I can assign one protocol. Whatever task I am doing, for the same task I am assigning one protocol. Protocol is also similar like me. This is nothing but a program, code, instruction, which is going to do my job. So if my machine is automatically attaching the address for each types of information to send to other machines, that means there is some protocol behind it. And this protocol was, guys, different before OSI model for all the different vendor devices. So adding these extra information with actual data to send the data to the correct destination is called task. I'm talking about this task only. Right? So this protocol was earlier vendor specific. Nowadays it is open standard. Whatever protocol machine A is going to use to add IP address, same protocol machine B is also using. Whatever protocol machine A is using to add MAC address, machine B is also using same protocol. Both protocol can communicate with each other. Both protocol can communicate with each other, and this is the reason why two different vendor devices are able to communicate, because their process, their protocol standards are common now. Both have designed their hardware and software according to the OSI model. Both have designed their hardware and software as on the basis of OSI model. So what I told you, why we come up with OSI model? To make communication possible between different vendor devices. Why different vendor devices was not able to communicate with earlier? Because their protocols, their rules, their process of communication was different. Everyone were using vendor specific protocol. Now let's understand what is OSI. Why is clear? Any question in why part? Any question in why part? Anyone? Why is not clear to anyone? Please stop me and ask. We are going to learn these all protocols, right, for IP, to add IP address on the machine, or to add MAC address or other informations in detail, in very detail. That is our work only. Every day we are going to do same in the network. So definitely we will learn it. Just an overview. For an example, PC1 is going to use IPv4 protocol to add IP address with actual data. PC1 is going to use ARPA protocol to add MAC address with actual data. PC2 is also using same. But guys, if here I have IPv6, then can these two devices communicate? Here if I have different protocol for IP, addresses. At layer 3, my encapsulation protocol is different. Let's say IPX. Can these two devices communicate then? No. That was the issue earlier, right? But nowadays, the encryption algorithm, hashing algorithm, protocols, everything is. OSI model is nothing but a common process of communication protocol, set of protocol, group of protocols. This is not a single protocol, group of protocol. But if I am going to tell you what is OSI model in very easiest language, then definition of OSI model can be it tells how data will or how data can out from a device and how data can enter a device. Like if I will talk about example in this scenario, so how PC1 is going to out the traffic, out the data from this port, and how PCB is going to process the data on this port. That is OSI model. It is similar like how you are leaving your room for the office and how you are entering in the office, or when you are coming back to the home, how is your behavior. So many protocols are there, but kind of task similar like us taking trash, putting letter in the envelope. These are what task. Now guys, okay, OSI model isn't task, fine. OSI model is kind of tasks, right? Multiple tasks will be performed at the time of data transmission and at the time of data. When device is receiving the data, it will perform multiple tasks. When device is sending the data, it will perform multiple tasks. And I already told you these tasks are nothing but adding extra information with actual data, right? It can be, the task can be, here I am writing, task can be done. The first task can be generating the traffic, generating data. So in the browser, if I am going to type google.com, first my machine is going to generate one request for Google server. Machine is going to generate one request for Google server automatically. That means one protocol is running there. Who is responsible to generate the data? And protocol, example of protocol is HTTP or HTTPS. It can be HTTP or HTTPS. To access web page of any website, any server, we have only two protocols, HTTP and HTTP. So that protocol will work to generate the data. Then second task can be generating the data. Second task can be encryption, means encrypting the data. Encryption, because if I am going to send you, let's say $500, how I will send you through internet? Internet is, guys, public network, not secure. What if anyone will change the destination? So security is very important. Everything should be encrypted, everything should be secure. Later you will learn these all things for the security, how we are going to secure the data over public network. But encryption is also one kind of task performed by networking devices before sending the data. Encryption and decryption. While sending the data, device will perform encryption. While receiving the data, device will perform. Then creating the session is also one kind of task. If I am going to type google.com in the browser, my machine is not going to wait for reply message for lifetime. There is a specific time, guys, session timeout. You might have seen many times while accessing the website, error, session timeout. So whenever my machine is going to send any request to any server, my machine is automatically going to create one session, right? And on the basis of application, we will define the session timeout. So within that timer, if my machine is going to receive the reply, then fine. Otherwise, it will going to disclose the connection. Will disconnect the connection, and you will get error, session timeout error. So that is also one task. Next task can be adding port number with data. Port number is also one kind of address like IP address and MAC address. Then adding IP address with actual data, adding MAC address with actual data, adding MAC address with actual data, then converting data into bits. You know, computer understand only 0 1, right? So converting data into bits, right? These are what, guys? These are, now we divide this all entire task into some part, into 7 part. Now before talking about this 7 part, you tell me why we divide anything. Why we divide anything? Just think and then tell me why we divide anything. Then I will come to this point, why I have divided this all entire task into 7 layers, into 7 part.
Arranging in proper manner.
Okay, that is also fine. Anything else?
Sir, segregating of task sequentially. That
And better understanding and troubleshooting.
Okay, tell me the answer of this question. If I will give you a book of 1000 pages, 1000 is, but there is no unit, there is no chapter, there is no page number. Can you read that book? Only 1000 pages are there, or 2000, but there is no unit, not chapter, nothing. You can read, but think how complicated, very complicated. So that's why we divide the book into chapters. Why we divide? Make it easy for those who are going to read this book. We divide anything to make that thing easy. That's it. That is the reason of division, according to me. Dividing means making it easy. So this, if this task is so complex, then it will be very difficult for me to teach you. How I can teach you? How I will teach new engineers who are completely fresher? By dividing into multiple parts. Yes or no? So the lots of things are going to happen on both the machine while exchanging the data. And as lots of tasks are there, it is very complicated to make understand to others. Divided into some parts. Into how many parts? We divide it into 7 parts. By the way, OSI model is not the actual implementation. This is just a theory. First we design the theory, after that we design one another model which is exactly same like OSI only, and which is the implementation one we have implemented in the network, which we have distributed to companies. So first of all, about OSI model, a common organization have designed one common process of communication and they use it as a blueprint. Why I'm saying as a blueprint? Because first I have, guys, make one process, one protocol, and after that I'm going to write down the complete process in the notebook. Like, see, whenever civil engineers are going to construct the building. So before constructing the building, they guys are doing what? They guys are creating the blueprint, their design, how the building looks like, how many floors are there, right? Where is the door, where is the bedroom, everything. First, they are going to create the blueprint, right? And after that, according to that blueprint, they are going to construct the building. Am I right? In the same way, OSI model is similar like that blueprint. This is just a theory that this way we can create the hardware, this way we can create the software, then two devices or more than two devices can communicate. And now, on the basis of this theory, I have created one practical model that is called TCP/IP model. TCP/IP model, and then we have distributed this TCP/IP model to every vendor company. That brother, now whatever devices you have manufactured that are, if you are not going to modify it, you are not going to modify it. Now you have to design your hardware and software in this way. In this way. So even the vendor company don't need to destroy the previous devices, because guys, if I will talk about the laptop or a computer, in the computer, entire computer is not used for communication. Entire computer is not used for computer. There is one NIC, as I told you, network interface card, which is going to connect my device to network. So whatever functions are there, protocols are there to exchange the data, that they need to replace, that they can reuse the. Okay, so in TCP/IP model we have 5 layers. In OSI model we have 7 layers. So we divide all the tasks into 7 part. First layer is called application. Second layer is called function. Third layer is called session. As I told you, device is going to create the session, maintain session, terminate session. So session layer is responsible for that. As I told you, HTTP protocol is responsible to provide you web page. Application layer uses HTTP protocol, works at application layer. I told you about the encryption. So presentation layer is responsible for encryption. Then we have transport layer. Then we have network layer. Then we have data link layer. Finally, we have physical. Which layer is the layer 1 or layer 7?
Application layer is layer one.
No, this is
Okay,
going to
okay.
be also very
Physical
interesting.
layer.
Physical layer.
Okay, physical. Okay.
No, not physical, not application. Then I will tell you, don't worry.
It depends. Sender and receiver.
Don't worry, guys. These are the fundamentals. Very, very important to understand. So, what did you first? Why? Then, what is OSI model? Have any question in these two parts? What is nothing but task that machine will perform while sending the data, while exiting the data from the port, and while receiving the data on the. Is what is OSI model? OSI model, you can say OSI model is a process which tells how computer is going to out the data and how computer is going to enter the, or how data will be processed by a machine while transmission, and how data will be processed by device while, and these are the task. These are the task. We divide the entire task into 7 parts. Some task will be performed at this layer, some task at this layer, some task at this, some at this, some at this, some at this. At each layer we have protocols. Understanding these layers teach you how OSI model. Okay, can I start? Before the starting, I am going to write some protocols here. If I will talk about the application layer, so here I have some protocol HTTPS, HTTPS, have FTP protocol, file transfer protocol, have TFTP protocol, have SNMP protocol, have SM or telnet, have SSH, we have what what else? Many protocols are there. Tell me some name of some application protocols. The busy here, top 3, and NTP work time protocol, syslog. So these are here. There are some popular application here. In TCP IP model, we have combined these for 3 layers. One thing, first thing about this layer is what? First thing about this layer, divide again 7 layer into 2 part, upper layer and lower layer. Upper layer and lower. Upper layer means, lower layer means 4 transport network data physical. Guys, generally software developer and software tester works on upper layer. Software tester, software developer, I am saying software engineer. For designing the software, who is doing the code, design the protocol or software, they guys are responsible to work on this layer. And on the lower layer, who is working? Work. Our work will start from here only, from the transport layer only. And why we are learning the upper layer? We are not going to learn the upper layer in detail, but you have one overview, because the protocol, there are some application layer protocols we are going to in networking, which we are going to use in networking. That's why we have to know about these layers also. And we need to master some application layer protocols like telnet. Telnet is networking. SSH is networking, BGP is networking protocol, NTP is networking protocol, SNMP networking protocol, HTTPS networking protocol. So we don't need to go in detail about these 3 layers, upper 3 layer, but here we have to master on lower. Okay. So you don't need to learn what protocol we are going to use for encryption, what protocol we are going to use for creating the session, maintaining session or terminating the session, but what protocol we are using at transport layer is so important. At application layer, you only need to learn these protocols. That is, this is more than sufficient about the application, because these are networking protocols. So that's why we need to learn these protocols here. Even you have to master. But I will talk about the transport layer, guys. This is your part. This is your part. You have to master it. Whatever protocols are there, and we have 2 protocols here, by the way, TCP and at network layer. We have so many protocols. We need to master IPv4, then IPv6. We need to master EIGRP. We need to master OSPF. We need to master Tell me some other protocols.
ISIS.
ISIS is layer 2 protocol. Okay. Then data link layer. At data link layer, you need to learn few protocols only, like ARP, ARPA, triple P, and few more. And physical layer, at physical layer you need to learn pulse or point and and now another thing here I have all the layer. That also if you are not able and station, transport, a link, and physical. Now guys, which layer is the layer 1? Is the layer 1, right? So for an example, here I have one computer, sender machine, this is sender machine, and this is per machine. Sender and so which machine will generate the traffic first? Machine will generate the
Sender.
sender
Sender.
machine will generate the traffic first at which layer? At application. It can generate traffic at transport layer also, network layer also, data link layer also. We will see later. For now, you can say at application layer, sender machine is going to generate traffic. Then sender machine will hand over the traffic to presentation layer. Then presentation layer will hand over to session layer. All the layers will perform their task and then hand over it to lower layer. Session layer will perform task. Whatever tasks are defined to the session layer, it will perform. Then it will hand over to transport layer. Whatever tasks are defined at transport layer, they will perform. Then it will hand over to network layer. Then network layer will perform their own task and then it will hand over to data link layer. Data link layer will hand over their perform their own task and then it will hand over to physical layer. And physical layer will transmit the data from the physical, right? Now receiver machine is going to receive traffic at which layer, guys? Physical layer only. So physical layer will receive the traffic, then it will hand over to upper layer, lower layer. Whatever task was performed by data link layer over here, whatever protocol we have used over here at data link layer, same protocol is going to work in reverse direction. Let's say here data link layer have added source MAC, a destination MAC. So data link layer over here is going to remove source MAC and destination MAC from the, let's say network layer have added source IP and destination IP 10.1, destination 10.2. So network layer over here is going to remove address. This is similar like sending a letter. Let's say you are going to send one letter to your friend. So this is your letter. Here is the actual information. Now you have put it the letter in the envelope. You have put it the letter in envelope. And on the envelope you have added source and destination address. And now you are going to send it to your friend. When your friend will receive it, first your friend is going to remove the envelope. Yes or no? Here is the letter. Your friend is first going to remove this envelope. Before that, it will check destination address. Is it for me only or not? If yes, then only they will remove it, and after that they will pick the. So guys, why we have added source MAC or destination MAC, source IP, destination IP, just to send it to correct destination device. Why you have added source address and destination address on the envelope? Send it to your friend only. But that is not the actual information. That is not the actual information. Envelope is not going to carry actual information. Actual information is inside the envelope. In the same way, actual data is here at application layer. So my application layer at receiver machine is going to get actual data. That's it. This rest all the layers are responsible to perform some kind of task. And the same task will be performed in reverse direction on receiver machine. So data link layer will perform the task in reverse direction. After that, it will hand over the traffic to network layer. Again, network layer will perform task in reverse direction. Then it will hand over to transport layer. Again, transport layer, and all the layer protocol should be same. Protocol should be same, but protocol will be same, guys, always, because both machines are designed on the basis of OSI only, correct? Then transport layer will hand over it to session layer. Session layer will hand over it to presentation layer. Presentation layer will hand over it to app. And here application layer will get actual data. So at sender machine, application layer is going to be layer 1. Yes or no? At sender machine, physics application layer is layer 1. Am I right? Presentation layer is layer. Session layer is layer 3. Transport layer 4. Network layer 5. Data link layer 6. Physical layer 7. Am I right? Am I right? But guys, at the receiver machine, which layer is the first layer?
Physical layer.
Right? At receiver machine, this is layer 1. This is layer. This is layer 3. This is layer 4. This is layer 5. This is layer 6. This is. So when I am asking you, application layer is which layer? Layer 1 or layer 7? You should ask, brother, tell me on which device you are asking. On sender device or receiver device? No. Then only you can answer. Directly we cannot say which is layer 1 or which is layer 7. At sender machine, application layer is the layer 1. At receiver machine, physical layer is the layer. Here. Till here.
Yes.
Yes, sir.
Yes, sir.
Now let's understand all the layers one by one. First of all, I am going to teach upper 3 layer. Upper 3 layer, because we are not going to learn detail about upper layer. What we will learn in detail about upper layer is only application layer protocol. Application layer protocols. These protocols we are going to learn in. Apart from these protocols, you should only have idea about upper layers. That's it. What is the function of application layer? What is the function of presentation? What is the function of session layer? That's it. That is more than sufficient. Then we will learn these protocols. So later I will talk about these protocols. For now, first of all, let me tell you what is application. So anyone have definition of layer? What is application?
Like like what you're using right now. on the
Yes,
screen what it is.
correct. Right. Application layer provide what? User interface. See, if you are going to access the Google web page, so you need what? One application through which you can interact with Google server. So that interface is nothing but application layer. I'm using Paint right now to teach you. So Paint is also one interface between user and actual application. Application which provides an interface in user actual, like to access web page, I need a browser. Send email, I need a Gmail application or email application or any other application. To send a file, I need application. Send any kind of data, we need what, guys? Application. CMD is also one application, Paint is also one application, browser is also one application, your Google Meet is also one application, Gmail is also one application. All are nothing but the application. And here, what we need to learn? Networking. Working. Working protocols on. Then next layer is presentation layer. And then what is presentation layer, guys? This here is responsible for compression and for an example, I have one file whose length is 1 GB. I want to send you. I have only WhatsApp, but WhatsApp is not allowing me send the data whose length is more than 10 MB, let's say. So what I can do, I can compress my data first. I can convert it into WinRAR, zip file, and then I can send it to you. And after that, you can again decompress it. So reducing the size of data at sender machine and decompressing at receiver machine is responsibility of this layer. Encryption. Encryption means changing the format of data so that unauthorized user cannot read it. Sender machine will always perform encryption before sending the data, and receiver machine will perform encryption so that no one can read the data between the source and destination. The next layer is session layer. Session layer is responsible for getting, cleaning, and terminating whenever I am going to send any request to any other device, session layer is going to create one session and it will maintain that session. Because of session layer only, we are able to use multiple tab here in the same browser. Right? Guys, who have idea about these tab? that whenever WhatsApp message will come, then I need to open that in this browser. Whenever any message will come over here from the Google Meet, I need to inject in this tab. Here I am running Facebook. I have opened the Facebook. If anyone will message me on Facebook, my machine will open that, will hand over at that to this tab. Who is responsible for these all things? Session layer. So session layer have created the session for each and every connection which your machine have established. The machine have established. When you are going to close the tab, your session layer is going to terminate the connection. Your machine is now free. One port will get free. So these are the basic overview about the upper layer protocols. Here, you don't need to learn more about these layers. Only we have application layer protocols. Just let. Class is going in one direction only. Why? Why it's not
Sir,
bi-directional?
I have one question. Sir, anyone asking me, tell me the packet flow of the OSI model, then how I explain it in application layer or in physical layer?
From the application layer, you will start from the physical. Let's say someone is asking me. By the way, you can answer to this question after learning the protocols. But for now, let's say I am asking you that this is your PC, and in the browser you are going to type www.google.com. What will be the packet flow? First of all, here DNS lookup will happen. My machine will check what is the IP address of google.com. Once my machine will resolve the IP address, my machine is going to generate request message for Google server. And what I told you, if machine is going to perform any task automatically, that means protocol is running behind the scene. And to access the web page, we have two protocol, HTTP or HTTP.
HTTPS.
So my machine is going to call this protocol. Hey, HTTP protocol, come here. Someone have requested to google.com. And HTTP protocol is going to get HTTP as request message. This is HTTP message. There is no address. Nothing is there. Only HTTP request. Right? Only HTTP protocol can understand it. No any other protocol can read this information. We cannot understand. You cannot understand. If you are the software developer, you can understand the code. That's it. Now, this is the only task of HTTP protocol at application layer. So here, what application layer did? Application layer generated one HTTP. Application layer HTTP protocol has generated one HTTP request message. After that, my HTTP protocol is going to hand over it to presentation layer, will encrypt it, compress it, and then hand over it to lower layer to session layer. Session layer is going to create the session, and then it will hand over to lower layer, transport layer. Here, your actual task will start. The networking task. Now, transport layer is going to decide the communication is going to be reliable or unreliable. Again, there are two terms. What is the meaning of the full reliable and unreliable? Reliable and so reliable means when we have acknowledgement, that particular thing is called reliable communication. If there is no acknowledgement, that particular thing is called unreliable. For an example, I need a glass of water, right? And I know my brother is sitting in the next room. My brother is sitting in next room. If I'm going to say, hey brother, give me a glass of water. Guys, am I sure that my brother is coming with a glass of water? 100% can I say? No, I don't know my brother have received my information or not. There is no any acknowledgement, right? But before sending the actual information is I need a glass of water. That's it. This is the actual information. But before sending this actual information, if I'm going to call to my brother, hey brother, name of my brother is Vivek. Hey Vivek, are you listening me? And he is going to say, yes bro, I am listening, you tell me. And now if I am going to send the actual information, give me a glass of water, this communication can be known as very reliable communication. This time I am sure that my brother will come with a glass of water only. Yes. Right?
Yes, sir.
Your communication is going to be reliable or unreliable. Who will decide? Transport layer. Right? Your communication is going to be acknowledgement based or without acknowledgement based. Who will decide? Transport layer. Okay? This is just one function of transport. There are many other functions as well.
Sujit, Sujit, can you answer? If you can hear me?
Yes, Amjad, we can hear.
Yeah, okay. Were you asking about the order of the layers?
Sorry, brother, I was on
You,
call. Can you
okay,
repeat?
all right. He's back. No, no, it's okay. It's all good.
Okay. So, if I will give you one simple definition of transport layer, right? Many more things we are going to discuss about transport layer, but for now, transport layer, this layer is add port number with actual. What is port number? Port number. So number is also one kind of address. Guys, see, the sender machine have generated HTTP request message. It hand over to transport layer. Directly, you can jump from application layer to transport layer. You don't need to care about presentation and session, because what I told you, OSI is not the implementation. OSI is just a theory. If I will talk about the implementation, TCP/IP, TCP/IP. Let me talk about TCP/IP first. Then I will again come. In OSI model, we have 7 layers. In TCP/IP model, we have 5 layers. First one is application layer, then transport layer, then internet layer, then physical. What is the difference between OSI model and transport? Nothing. Just we have combined upper 3 layers into the single layer. Right? Whatever task will be performed by application, presentation and session in the OSI model, all those tasks will be performed by single layer in TCP/IP model. That is, whatever task will be performed by transport layer in OSI model, same task will be performed by transport layer here in TCP/IP model. Whatever task will be performed by network layer here, same task will be performed by internet layer here. Whatever task will be performed by data link layer, same task will be performed here physically. So we have combined, right? So we will not talk about presentation and session. Directly we'll jump to transport from the application, right? So here, let's say a sender machine, a machine computer have generated one HTTP request message at application layer. then it have hand over to transport. At transport layer again we have data. Now after that it will hand over to network, then data link layer, then physical, and then physical layer will transmit from the link. After that server is going to receive data. Again server will receive at physical, then it will hand over to data link, then network, and the network layer will hand over to transport. Guys, now tell me how transport layer will get to know about the actual protocol. That okay, I have some data, but to whom I need to hand over it? There are so many protocols at application layer, so many protocols at transport layer. To whom I need to give this data? So that's why to identify the application layer protocol, we are using port number at transport layer. Port number at transport layer. So what can be the definition of port number? It is a unique identification of all application layer. Right? Guys, each and every application layer protocols are using one unique number, unique identity called port number. And who will add port number with actual data? Transport. So sometime you might have seen the question in interview. Interview is asking, hey, my PC is able to ping Google server but not able to access web page. That means we need to troubleshoot transport layer. We need to troubleshoot the port number. Right? So the first task of transport layer is adding port number. We will talk more about port number later. Definitely we'll discuss more about port number. There are two types of port number, well known and unknown. We'll see those all. The other function of transport layer is this layer decides reliable or reliable also this layer also decides connection oriented or connection, or we can say communication is three-way handshake or three. Right? Connection oriented means there is involvement of three-way handshake. Connection oriented is similar like, as I told you, before sending actual data, I have created the connection with my brother. And connection less means directly I am sharing the data, actual data. So there will be no any acknowledgement, right? And guys, if you are thinking that every time we are going to use reliable communication, connection oriented communication only, so again answer is no, wrong. Whenever we need fast communication, then we are going to use this method, connection less. For example, video conference. Right now we are connected through Google Meet. Here we need fast communication. If there is internet issue, then you will lose the information. My machine is not going to retransmit the missing information, right? Because this is connection oriented. Retransmission is not possible. So transport layer is also going to decide retransmission is possible or not, right? Whether the communication should be connection oriented or connection less. In connection oriented, before sending actual data, sender machine will establish a connection with receiver machine. In connection less, directly my machine will share the data. Okay. And don't worry about the connection oriented connection list. Less I will give you many more examples, right? So this is just basic overview about transport layer. Then guys, transport layer will hand over to network layer, lower layer, and network layer is responsible for layer is responsible for adding layer 3 address, which is nothing but IP. So network layer is responsible to add IP address with this is the main function of network layer. After that, after adding address, it is going to hand over to lower layer, data link layer. And data link layer is responsible to add MAC address. Layer is responsible for for adding layer 2 address is MAC address with data. And then finally, data link layer will hand over to physical layer, and physical layer is responsible for converting the data into bits and bits into signal. Physical responsible for converting data to bits, then bits to signal, depending on link type. It will depend on link type, in which form my device is going to transmit the data over the. So this is just overview about OSI. Now why I told you don't need to write down anything in the class, because guys, I have already a note for these all. Is already available on the drive, right? Maybe today I will add all the mail ID. I was waiting for mail ID. That's why till now I have not shared the study material, but today you will. For each and every topics, I have what I told you about the transport layer. This layer provide reliable or unreliable delivery. It perform error correction before transmission. We will talk about this. Two main protocol works at this layer. TCP stands for transmission control protocol. The different. TCP connection oriented is connection less. So I told you that transport layer protocol is going to decide whether communication is going to be connection oriented or connection less. So there are two protocols, TCP and UDP. P is connection oriented, UDP is connection less. So whatever protocols we have which uses TCP protocol at transport layer, those all are going to be. Whatever protocol we have which uses TCP at transport are going to. What I told you about network layer information. Network layer provides logical address, means IP address. Router and layer 3 switch works at this layer. The main function of router works at this. The main function of router works at this layer. Main function of router is working at network layer. Okay. Protocol used at this layer is IP, EAGRP, OSPF, ICMP, many. Then what I told you about data link layer. Same data link layer provide physical address. It perform error connection. These are the detailed information. We'll see it. Right? What I told you about application layer already mentioned it. Application layer. Application layer acts as an interface between user and actual application. This layer tells user that application is internet based or not. If you are going to send file between two computers, maybe internet is not required. If you are going to access Google page, internet is required. So application layer is going to decide that the internet is required or not required, right? It will understand. Various services, there are various services like web page, like accessing the web page, accessing the file service, accessing networking devices remotely, synchronizing the time on multiple devices, sending mail. These are what services, and these all services can be accessed by using kind of protocol. With the help of protocol, these all services are accessed with the help of some protocol like FTP, SMTP, FTP, DNS, DHCP, app developer design. Presentation layer. At this layer, data is presented in the standard format. Data can be encrypted, decrypted, compression, decompression. At this 1 to 3 can be encrypted into ABC, and again ABC can be encrypted 1 to 3 at session layer. Session layer create, maintain, and terminate session. This can be done with the help of session ID. It keep data different sessions separately. So now I am expecting you have basic idea about OSI model. Yes.
Yes, sir.
Now we need to discuss protocols, port numbers, like what I told you at transport layer. Have two main protocol and PP, and at network layer. Now we are going to learn IPv4 protocol only. At data link layer, ARPA protocol we are going to. So these are encapsulation protocol, guys. Encapsulation protocol means who is going to add extra information. Encapsulation and decapsulation, these are two very important terms of computer networking. And first one is encapsulation, second one is decapsulation. And what is encapsulation? What is decapsulation? Encapsulation means adding extra information with actual data. Like transport layer is going to add what? Port number with actual data. Network layer is going to add what? IP address with actual data. Data link layer is going to add what? MAC address with actual data. So this process is called what? Encapsulation. And decapsulation means moving extra information. Guys, am I going fast or slow, or it's perfect? Fine for everyone?
It's a little bit fast for me.
Fast, okay. Thank you. What about others? So now I will slow down the speed. So encapsulation. Now, encapsulation means adding extra information, and decapsulation means removing the extra information. When you are sending the letter, you are adding letter in the envelope and your friend is removing envelope and picking the letter, right? So you are performing encapsulation, your friend is receiver machine is performing decapsulation, right? So if I have two machines, one is sender, one is which machine will perform encapsulation? I have one file and I need to send this file PC2. One want to send this file to PC2. Which machine will perform encapsulation?
Sender.
Sender, right? And which machine will perform decapsulation?
Receiver.
Encapsulation means here send the file, we have FTP protocol. So FTP protocol is going to generate the actual message, right? After that FTP will hand over it to transport layer. Transport layer is going to add what? Port number. Then transport layer will hand over it to lower layer again. Network layer. Network layer is going to add what? IP address. And then it will hand over to lower layer, data link layer. Data link layer is going to add what? MAC address. MAC address. So this particular thing is called encapsulation. Particular thing is called encapsulation. Receiver machine needs this information only, this actual FTP message. But to send this actual FTP message to the correct destination, we have added these all extra. Send this data to the actual machine. I have added all extra. So when receiver machine is going to receive it, whatever extra informations are added at data link layer, at the same layer, whatever informations are added at network layer, at same layer, that information will. So that's why protocol should be same, and all is same IP. Whatever informations are added at transport layer, moved here, and then cover the actual message. This way, these two machines are going to so hope encapsulation and decapsulation is also. If it is not clear to anyone, you can. So basically, we are here talking about three extra informations: port number, IP address, and MAC address. So why not to learn these three types of addresses first in detail? Yes or no?
Yes, sir.
Yes.
Let's start from port number. First, we are going to start port number, then we will start MAC address, then we will discuss IP address. After that, again, I will come to IP model and we will discuss the application layer protocol, and after that, we'll see the complete packet flow. Once I will discuss the complete packet flow, then we can like start implementing it the packet in the simulation. We can start doing the. By the way, now also I can show you these all things, these extra information. How many of you know about the ping, guys? How many of you know about the ping?
Yes.
Ping is an utility which is used to check connectivity between devices. Check connectivity between two devices. So simply in the browser, let's say I want to check is there any reachability between my computer and Google server. I can ping 8.8.8, the IP address of Google. server, and you can see I'm getting the reply. That means there is IP reachability. Or I can ping google.com also, ping www.google.com. Again you can see I'm getting reply message. That means there is reachability. But guys, here again I have only run this command ping and the IP address or domain name. Automatically my machine has generated some kind of message, right? I am getting reply from guys Google server. Right? There is reachability. That means definitely my machine have sent some kind of message and it is ping. I have sent the request and it is the reply. So how automatically my machine has generated the message? Definitely protocol is there. And ping uses which protocol? It uses ICMP.
ICMP.
It uses ICMP protocol. Now what is ICMP protocol? So ICMP is a layer 3 protocol. ICMP stands for Internet Control Messaging, which works at which layer? It works at layer 3. Now, need to learn one more thing here. What is the meaning of point? It works at layer by this. What I told you, HTTP protocol works at which layer?
Application.
HTTP works at application layer. ICMP works at network layer. EIGRP works at network layer. TCP works at transport layer. The meaning of any protocol working at a particular layer is nothing but their messages. Their messages. Like HTTP works at application layer, means HTTP protocol is going to generate their all messages at application. If I am saying TCP is an transport layer protocol, works at layer 4, means TCP protocol is going to generate their all messages at transport layer only. And if a protocol is generating message at transport layer, guys, is there any involvement of application layer or session layer or presentation layer? Any involvement of this layer? If my transport layer is going to generate the traffic, then there is no involvement of upper layer. If network layer is going to generate the traffic, there is even no involvement of transport layer, because network layer will hand over traffic to lower layer, not to upper layer, right? So if I will talk about ICMP, will not have any information about TCP, will not have any information about session layer, about presentation layer, about application, right? Directly you will find your data at network layer. So in the ICMP message, we will have ICMP request, and then ICMP protocol is now going to hand over it to IP protocol at same layer. If application layer is going to generate the traffic, then application layer will hand over to transport layer. Transport layer will hand over it to network layer. But this time, both the protocol, ICMP and IP, who is responsible to add IP address, works at same layer, right? So ICMP protocol have generated the actual ICMP request message. Now network layer responsibility adding IP address, right? So IP protocol is going to add IP addresses, and after that it will hand over to lower layer. Lower layer means data link layer. Data link layer is going to add MAC, and we can check it. Where we can check it? You can check it in packet tracer also. You can check it in DNS3 also by capturing the In the packet tracer, you can one. I can connect these tables. Anyone don't know how to use packet tracer, you can let me know. We'll take all session. Here I am going to configure one IP 10.1.1. Here I am going to configure IP 10.1.1. Let me configure the IP. Anyone have idea what will happen when I will configure IP on PC number 1? What is the first step? I will say IP 10.1.1.1. First of all, my machine is going to check, guys, duplicate. Is it the duplicate IP address, or for that my machine will generate gracious ARP. I will cover these all topics in packet flow, don't worry. Okay, your IP address done, done. Dot. See, when I configure 10.1, what it's saying, this address is already used in the network. Machine is checking the duplicate, so 10.1.1.2. I have configured the IP. Now see the connectivity between PC1 and PC2. I am going to check connectivity. For that I can ping 10.1.1.2 from PC number 1, and you can see I am getting reply message. That means there is reachability. Now if you want to see the packet, you can use simulation mode here. The simulation mode, I have turned on the simulation mode, and now I am going to see the packet. Which packet it is? Type of message it is? ICMP request message, right? Are you able to see, guys, ICMP on the screen? We will open this. You can see layer 3 header. In the layer 3 header, what is the information? Source IP, destination IP. In the layer 2 header, what is the information? Source MAC, destination MAC. You can check out. See, my machine have generated the ICMP message, this actual ICMP message, and this is the extra information added by network layer. And in the extra information, we have source IP, destination IP. We will also learn these all information right in the header class. And then this is extra information at layer, where you can see source MAC and destination MAC. Some extra informations are there like actual data, type, field, preamble. We will discuss about these. So this way you can check the basic things also, whatever things I have covered till here. Here. After that, my PC is going to send ICMP packet to 1. When I am typing ping, 4th time my machine will the 4th time, depends on operating system. Now come to the port number. So port number is also one kind of address. What I told you about port number, here also you can read. Same information. Port number is a unique ID of the protocol. Protocol application layer protocol. It is 16 bits decimal value. Port number. it is 16 bits values by there for the at transport. At transport layer, how we are going to differentiate the application layer protocol? With the help of port. Okay. At transport layer, how we are going to identify the application layer protocol? With the help of port number. So if the length of port number is 16 bits, then can anyone tell me the range? What will be the range of port number? 0 to 2 power 16? 0 to power 16? What is the value? 2 power 16?
16,002, I don't know, 2.
65535. Can check 2 to the power
Oh, yeah.
16
Sorry.
is
Yeah, that's correct.
right. And now we divide it into parts. This is the entire port number, right? Part first one is well known types of port. First one is noun, or we can say used port number. These are the port which I have already assigned to protocol. Like guys, what I told you, for accessing web page, I have two protocol, HTTP and HTTP. HTTP protocol uses port number 80 and HTTPS uses port number 440. So these two ports are well-known port number because I have already assigned 80 port number to HTTP protocol. No one else can use this port number, right? So doesn't matter from where you are going to type www.google.com in the browser. Every time destination port number will be what? Either 80 or 440. That's why we are saying this is non-port number, well-known port number. But what about source, guys? That is fine. Destination is 80 or 443, everything. What about the source? Source is variable, right? Destination is either HTTP or HTTPS protocol, but source can be Google Chrome, it can be Mozilla Fire, it can be UC browser, it can be Opera Mini, it can be your laptop, it can be my laptop, it can be your mobile, it can be my mobile. Source can be anything, right? So is source noun, guys? Is source fixed? Destination is fixed. Destination is fixed, but source is variable. So my device is going to use which port number as a source port number. So that's why we have another type of port number called free port number. Free, which are free ports, free, which we can use as a source port number. Here also you can see range of well-known port number is 0 to 102, and range of unknown port number or free port number is 10252 553. So let's say this is my laptop. This is your laptop, right? We both are connected to the internet. You are also connected with google.com. Also connected. My laptop is also connected. Now in the browser I am going to type www.google.com. So what will be source port number here? Any port number from free range, it can be 1025, but destination port number is fixed. That will be 443 HTTPS. When you are going to type www.google.com in your browser, maybe your computer is using port number 1030, but destination port will be again what? 443, because 443 port number is already assigned to HTTPS protocol. Yeah, is it clear? So whatever port number we have already assigned to the protocol are called well-known port number, and the port number which are freely available are called unknown port number, which we are using as a source port, which we will use as a source port. Okay? And these are some important protocols which you have to remember what port number they are using, like TCP. Sorry. See, these are application layer protocol for network engine. Many other protocols are also there, but these are so important. Guys, what you need to learn about these protocols? You need to learn two things. Important things you need to learn about every about every. First one is protocol are at transport. First thing is which protocol they are using at transport here. And guys, second thing is what is the port number of that protocol. This is so important for network troubleshooting, right? So you can see here, these are the important protocol. First one is FTP. FTP uses which service at transport layer? And what is the port number? 20 and 21. SSH uses which service at transport layer? Both TCP and UDP. And what port number? Telnet uses TCP service at transport layer and uses port number 23. SMTP uses TCP protocol at transport layer and using port number 25. DHCP uses UDP and using 2 port number. POP3 is using TCP and 110 port number. NTP uses UDP and 123 port number. HTTP uses TCP and 80 port number. HTTPS uses TCP and 443 port number. Like this, you need to learn application layer protocol. A point. Like this, you need to learn application layer all here. Here till here, guys.
Yes, sir.
What happened? Death. That's sir. Home lab. Alam. Yes. Abhishek.
Yes, that's clear.
So whatever topics we have covered, these are the basic topic. Revise it and continue from here the next week. So next weekend, what I told you, first we are going to cover these three types of address. So port number I have already covered, port number, and make sure you will learn more about it. More about it means you can perform the lab, you can check the port number in the packet tracer. Next type of address is IP address and MAC address. So first I will start MAC address, next weekend MAC address, and then see IP, after that subnetting, and then again I will come to application layer protocols and header. Right? Yes, in the headers there are some other fields also, so we'll see those all fields. In the header, whatever fields are there, we will see all the field one by. After that, MAC address, IP address, then packet flow. After that, you can understand the packet flow very easily. For now, here, if I will show you the port number, for an example, in the browser, the DNA. .1. Now, if I am going to type www.google.com, my browser will generate DNS message. Here you can see. So you can verify the port number, what services they are using at transport layer, which service it is using, TCP or UDP. What is the port number of DNS? 53. And you can see it is using random port number for as a source port number, unknown port number. Destination is well-known port number of DNS. So guys, few things you need to remember also, like port number of a protocol. Here I can not do anything. You have to remember the port number of some protocols. As a network engineer, you should have idea about 10 protocol and with port number and their services at transport. 10 protocol, right? So you can remember the port number of HTTP, port number of HTTPS, and their services also, like transport layer service, your UDP, and the port number. Then you can remember the DNS, you can remember the DHCP, you can check the telnet port number and SSH 1, 2, 5, 6. So these 6 are also sufficient for now. Right? So in the next class, I am expecting you will have idea about the protocol TCP or UDP, which protocol is using or which protocol is using, and about the port. That's it. Apart from this, you don't need to remember anything.